Hello students, welcome to In 5 Minutes. We'll continue with type 2, that are proofs on analytic function. Now it is given that if f of z and f of z bar are both analytic, prove that f of z is constant. Let's start with solution. Let us consider f of z as u plus iv. Then I can say f of z bar will be u minus iv, that is nothing but a conjugate, or else I can also write as u plus I minus v. So since it is given f of z is analytic, so therefore you can say ux is equal to vy and uy is equal to minus vx. So if I say this is a CR equation when f of z is analytic. It is also given that since f of z bar is analytic, when this is analytic, the change will be, see, that's why I have written here u plus minus v. Then your change will be, now ux will be equal to minus vy and ui will be equal to minus of minus vx. So which will be, I can say ui is equal to vx. Now from here I got two equations. I can say this as 1 and this as 2. So what I do, so I add my, in equation number 1 first condition and in equation number 2 second condition. When I add this equation, what I can get, so I just define here by adding, let's name, there should be no confusion, so let's do one thing. Let's name this as equation number 1, equation number 2, equation number 3, and this as equation number 4. So what I'm telling, by adding 1 and 3, so once you add 1 and 3, you'll be getting 2ux, that is LHS plus RHS. So I can say ux is equal to 0. And by adding, now next is, in the same way I can add this. So from here I can get, by adding 2 and 4, I get ui is equal to 0. So understand students, when differentiation is 0, that means I can say that my function u, my u is a variable which is basically depends on x and y, it will be damn sure constant, because when differentiation comes to be 0, that means it should be constant. So I say, because of this two condition, let's name this as a and b. So I say, since from a and b I can write what u is equal to, I can say it's a constant. And similarly, as u is constant, I can also get, similarly, when we want v as constant, now this minus when it comes this side, we can also write similarly, your vx will be 0 and vy will be 0. So therefore I can say v as also constant. So when u and v are constant, we can therefore say that as u and v are constants, therefore f of z is constant. That's the derivation completed. Now let's check one more.